The following interview has a video version that you can find right here on the Techstination website or on the Techstination channel on YouTube. Check it out. Welcome to Techstination. Joining us is Princeton professor, mathematician, author, and astrophotographer Bob Vanderbei. Thanks for joining us, Bob.
Thank you, Fred. It's great to talk with you.
Well, we should mention you are co-author of the National Geographic book, Sizing Up the Universe, which has many of your amazing images. You've got other books out there too, and I think in the more academic vein. What's even more amazing to many of us is how you capture many of them, which is right from home. Tell us a bit about that. I mean, you didn't get too much sleep last night, I don't think.
That's true. I was out taking a picture last night. I bought my current telescope 15 years ago, and it was shipped to my home here in New Jersey, and I bought a mount to put it on and a thing to put the mount on called a wheelie bar, a little thing with wheels, so I could just roll it in and out of my garage, and it just sits on I roll it out into my driveway, I get it oriented correctly, and I start taking pictures, and a couple hours later, I stop taking pictures and roll it back in my garage. And, you know, lots of astronomy people go to a dark sky location or something like that, but I've pretty much done it from my driveway here in suburban New Jersey, and with the right equipment and a little bit of understanding of how to do things, one can do that. And so I could tell you a little bit about some of those details. Would you like to hear a little bit of the details?
Yeah, tell us a little bit about the equipment that you use. Of course, you know, when we talk later, we'll tell people maybe how they can get into this a little bit, maybe without investing as much as you have in this. But you've obviously you've studied this to a great extent, and you're even working on improving things in terms of the imaging yourself.
Yes. So to take really good astrophotographs, it doesn't require a large telescope like most people think it does. I've taken a really nice picture with just a telephoto lens that I bought from the store in Princeton, a used telephoto lens. I think I bought it for $30. And I took a great picture with it. Now, of course, it wasn't just the lens. I had to put a camera behind the lens, and the camera wasn't that cheap. And then because the stars and the things in the sky, because the Earth is rotating, these things are moving. You know, the sun rises in the east and sets in the west, and all the stars and everything else do the same thing. And so you need to track the thing, because we're not just taking a snapshot for a hundredth of a second like we do in the daytime with a camera. You got to take exposures that maybe last a minute or 5 minutes, and you might want to take several of these over hours. And so you've got to be able to track the motion. And so getting a mount, that's what they call it. You mount your camera. So you have a tripod and then a mount, and the mount has to have a little motor in it that tracks. But you can buy these mounts these days for, I don't know, a couple $100. Some of the, not the big ones, but the smaller ones, and it'll track for all night if you want. And so one of the keys is to be able just to take lots of exposures over several hours. And that's one of the key things to getting a nice astrophotograph. The other one is a lot of the things we take pictures of are nebulae. That's plural for nebula. And these are clouds, and that's why the word nebula. Nebula means cloud, right? These are clouds within our galaxy of gas doing various things, and most of it is hydrogen, and most of that is emitting a certain wavelength, just one wavelength of light. Hydrogen alpha wavelength, it's called. For those of your audience who know about these things, it's 6,565 angstroms, which is red light. And so you can buy what's called a narrowband filter for like $100. And that filter only lets through that wavelength of light. And so you can put that in your camera, and all the annoying light pollution we have in New Jersey gets blocked, well, not all of it, there's a little bit at that wavelength, but you block out 99.9% of the light pollution, and you can take nice pictures. I've taken pictures in the daytime of some of the bright nebulae in the sky, just because the narrowband filter cuts out the daylight.
That's amazing. Have you noticed during this whole pandemic less light pollution at all? Has that been noticeable?
It has to me. I don't know this as a scientific fact, but just going out at night, it just seems like the skies are darker. Have you noticed that too?
Yeah, it seems to be, and I don't know what's my imagination. And well, you know, the air is supposedly a little bit cleaner too. But
Yeah, yeah, yeah.
now this has been a pretty exciting month. Looking at the night sky, I saw a great shot you took, not even with the telescope, as you were kind of
Right.
describing, of the comet Neowise.
Yeah,
So
yeah.
tell me about what's going on.
Yeah, so people didn't expect this to be a dramatically exciting comet when it was first observed approaching the sun. But as it got close, it got surprisingly dramatically bright. and, uh, and so this only kind of became a thing that everybody was talking about in the astro world a few weeks ago. And people started taking pictures of it. Now, it's a comet, so you got a bright thing and then a tail. And that tail's fairly large. I mean, as you look in the sky, I mean, it's maybe 2 or 3 times as the size of the length of the diameter of the moon, for example. You know, so if you look in the sky, you know, it's like this big. And so you don't want a telescope, because the telescope would be zoomed in so much you wouldn't see the entire comet. So you just take a picture with a regular camera, with maybe a telephoto lens. I didn't even use a telephoto lens. I just used the regular lens on my DSLR Canon camera, and I just set it up on a tripod and take pictures. But of course, there's some learning with that as well, and that is this. Again, like it's not a daytime shot; it's a nighttime shot. So it's not like click done. I started out taking 10-second images, and then I went down to 5-second images as the sun started to get closer to the horizon and daylight started to seem like it was happening. And so you have to set it on a tripod. The tripod should be nice and sturdy and stable, and then you take a 10-second exposure. And I took several. I took like more than 100, I think, over the course of 20 minutes. And then figure out which one's the best. That's one of the tricks to the trade.
Yeah, and that's one of the great things about a DSLR, right? You can keep taking pictures. You're not running out of film, and you can see what you've got instantly. You know?
Yeah, yeah. And it was, I got to tell you, it was really fun. Shall I do the share screen and show it to you now, or
Sure, you can show us the image.
you seeing it?
Yes, absolutely.
So there's
beautiful.
the comet. By the way, I don't know if you can see my cursor on my mouse, but when I went out early in the morning and I was looking for it, I went out in my backyard and I couldn't see it. And I'm just doing this with my eyes, naked eyes, not binoculars, not anything, just looking up in the northeast, because that was where it was rising at 4 a.m. and then I walked out into the street in front of my house, and I noticed right about here where I've got my mouse, I said, oh, there it is. And I set my tripod and started taking pictures when it was here. But then over the course of the 20 minutes, you know, it's rising in the east, in the northeast. And so it went from here up to here. In fact, I made a video of it, of my pictures, which I don't think I showed you. Here's the video version. It's only 7-second video. There it is, rising up. Can you see it?
I can. That's just amazing.
Yeah, so that was fun. So it's been a morning thing for the past few weeks, but it's moving quite fast. In fact, it's already gone past its closest approach to the sun, and it's on its way back out. And it's moving relative to the other background things in the sky, in the celestial sphere. And so it's been a morning thing, rising just before sunrise, but starting about now, it's becoming an evening thing. So tonight, if the skies are clear here in New Jersey, I don't know about the rest of your audience where the sky is, if the skies will be clear, but if you go just around, well, here in New Jersey, it's sunsets here in New Jersey around 8:30 now, but you still have dusk. It's not dark at 8:30. That's just when the sun technically sets. It's not actually dark for another 45 minutes as the sun slowly goes below the horizon. And so at around 9:15 or 9:30-ish is when the sky gets dark enough that you can see the comet, and it's low in the sky in the northwest. And so if you get out your compass, there's north, look to the left a little bit, look, you gotta be able to see very close to the horizon because it's very close to, it sets not long after the sun. And so 40 minutes after sunset, it's very close to the northwest horizon, but you should be able to see it. I tried to see it last night while I was setting up to take the other pictures. I tried to see it and I couldn't find it. But a friend of mine who went to the Princeton airport where the runway is nice and long, and then there's not many trees at the far end, so you can see all the way down to the horizon. He saw it and took a nice picture of it yesterday evening.
Will it be any higher off the horizon as the days progress here?
Yes. So tonight will be easier than last night, and in the next 3 or 4 days, it'll be something that will be easy to see at night.
And for how much longer do we expect it to be visible?
Actually, that's a good question, and I haven't paid attention. I haven't read all this stuff, so I don't know the answer to that.
But people can read their newspapers or look up information online about it. But the thing is, what I'm getting from you is that this isn't something that you better look right now. You have 1 or 2 minutes before it disappears. It's in the sky for
a week or two, yeah.
But I mean, you have maybe what, 15, 20 minutes to observe it once you find it?
Yeah, until it sets, just like a sunset, a comet set. Yeah, so yeah. And by the way, as days from now, maybe a week from now, it'll be even higher and you'll have a longer time before it sets. So it'll get easier as long as it stays bright. And that's something nobody knows. How long is it going to be as bright as it has been?
So that is a question mark.
Yeah.
What is it that drew you into astrophotography? Because this is not what you were originally doing.
Okay, so here's the story. So as a kid, back in the 1960s, it was something called the Apollo era. I totally loved the Apollo era. I wanted to go to the moon myself. And I grew up in Michigan, and we would go camping and the skies would be very dark. And when I was just a little kid, once I went out, I go, wow, that's beautiful. And so that's how it started. When I was just, like I think a lot of people, it's that way. When you're a kid, the first time you see the stars in the night sky, you're like, that's just amazing. And then the question is, do you pursue that or do you let it go and do other stuff? And in my life, the Apollo era ended when I was in 10th grade, and I went on with my life and did other things completely different. And until the year 1999, just 21 years ago, I was just randomly in my office at Princeton. I randomly was down the hall in another person's office at Princeton who was a friend of mine. And I noticed he had a calendar on his wall with an astrophotograph as its picture there. I go, oh, Kirk, are you interested in astronomy? And he said, yes. I'm the director of the Amateur Astronomers Association of Princeton. And he invited me to go to a star party that very weekend. And he said, so I joined him out there. There was probably like 100 people and probably 50 telescopes set up. This was out in Pennsylvania where the skies are darker. And he set his telescope up and he pointed it at Jupiter. And I looked at Jupiter through his telescope. Wow. You can see Jupiter. It's like we're there. I mean, it's amazing. And that's how I got interested. And a week later, I bought myself a telescope. And a year later, I bought myself a camera. And that's how it got started.
Yeah, like you described, I remember, lying on a lawn chair as a kid at night and spending as much of the night out there as I was allowed to, and just being the sense of wonder that you describe.
Yeah.
But the photography
Yeah.
takes this to such a different level. I mean, it's beyond just looking at things with a telescope, but capturing the images. Was that hard to learn? Is that something a lot of people can get into?
I think people can get into it, but there is a learning curve. Maybe I'll tell you a little bit more of the history. So when I bought the telescope, because we looked at Jupiter through my friend Kirk's telescope, it was beautiful right there, looking visually. Boom! I'm looking through the eyepiece, and it's beautiful. So when I bought my telescope, I looked at Jupiter, and it was beautiful, and Saturn, and some of the other planets, Mars. Um, but you see all these astrophotographs on his calendar, and I subscribed to the magazine Sky and Telescope, and you see all these beautiful pictures of things that are up there, and I would learn where they were, and I would point my telescope at them. I'm like, I can't see any, I can't see it. It's too faint. My eye isn't good enough to see this faint thing, but people took a beautiful picture of it. And the reason their picture is amazing is because it's like a couple hours of exposure where your eye, because it's like a video camera, your eye is taking an exposure 20 times a second or something like that. And it's not just collecting the photons over the course of 20 minutes and saying, look at the picture your eye just got. And so I tried for about a year and a half, I think, to see things. And I saw a few things, but some of the bright nebulae in the night sky, but only a few. And they weren't dramatically beautiful like they are in Sky and Telescope magazine or Astronomy magazine. They were just, you could barely see them. And so that's when I realized, oh, if you really want to do this and really want to see these things, you could go to Hawaii, go to the top of a mountain and get maybe a bigger telescope than I had. And I've done this, by the way, later years. And oh my God, I can actually see that nebula visually through a telescope here in Hawaii, or maybe New Mexico. But I think it's cheaper to buy a camera than it is to fly to Hawaii every 6 months and just do it on my driveway. And so that was kind of what motivated me to learn how to do long exposure astrophotography from my driveway. But yes, there's a learning curve. You got to learn the right way to do things. You got to learn there's software that does this, and it's very nice software, but you got to learn how to use it.
And it sounds from what you were saying before, just using the camera, that filters might be an important part of this.
Yes, filters are an important part of it. Filters are irrelevant for taking pictures of a comet. They're irrelevant for taking pictures of the planets, Jupiter and stuff like that. But if you want to take pictures of these narrow band and nebulae, then you need, you don't need, but you'll be much improved if you have a narrow band filter.
It seems that this might be a very good time, not just because maybe the skies are clear and things, for people and families that seem to have more time at home. Maybe turn the TV off. There's not much new on there anyway right now.
Yeah.
And spend some time looking at the sky and maybe getting into astronomy, perhaps astrophotography as well.
Yeah, yeah. And by the way, there's lots of really nice apps or web pages or things you can download to your cell phone. I have like 5 or 6 of them on my iPhone here, where it's an app, and I paid maybe $5 for it or something like that. But I load up the app and I hold up hold up my cell phone, and it shows me exactly what's in the sky in the direction I'm holding my phone, and it tells me, oh, that's the star called Capella, and this is the star called Vega, and this is what you're looking at, and there's the nebula that you can't see, but it's right there. And just to sort of learn your way around the night sky, I think, is one of the first things that's useful to do. And these apps, some of them are free.
Anything you recommend?
Let's see, what's it called? Sky Safari Pro, I think. Or you don't have to do the Pro version. Sky Safari is a very popular one. There's another one called Star Map. I think those are the 2 most popular, but I could be wrong. Apps they work on my iPhone. I think they also work on the Android phones. And they're really nice. You just click on it. You can search for an object that you want to see. Like last night, we were using Sky Safari to look for the comet setting in the west, and it shows us where to look. And so that's one of the fun things that's easy to get started. On my computer, I use a different software called, it's written by a guy in France. So the technical name is French, Cartes du Ciel. I'm not sure I'm pronouncing it exactly right. My French colleagues would tell me I got a weird accent. But Cartes du Ciel in English is sky charts. And it's free software. You can Google sky charts, download, and download it to your computer. It's both works on both Windows and Mac. And I've been using that software for 15 years, and it's just wonderful. So I use that software, by the way, to control my telescope's mount, but you can also just use it to, it's a planetarium program. You can use it on your computer to ask, what's in the southern direction right now from my home at this latitude and this longitude, and it will show you those things. And it's really, really nice software.
Amazing. And I guess for people to get started, it doesn't have to take a huge investment. Of course, if you're going to buy a telescope, you can spend a few hundred, or you can spend thousands, but it doesn't necessarily have to break the bank.
Right. So I don't know what to recommend at the more economical level, because I've sort of gone at the higher end. But you're right. You can buy a telescope that doesn't cost very much money, maybe $100 or a couple $100 maybe on a mount. I think, and then there's actually adapters that you can attach your cell phone to the hook it up to the eyepiece. I haven't done this, but this exists. And then there's apps that you can download. In fact, I have one here. Instead of using the camera software that comes with your cell phone, which just wants to take a picture in the daytime, there's specialized apps that know that you want to take astro photos. I have one here that's, well, this isn't necessarily for only astronomy. It's called manual camera. You can set the exposure, you can set all these things, the focus and everything. There's some other ones, I can't remember the names of them, but so you already have everybody has a camera. So you just need to buy a telescope. And the telescope, you can, for just a couple $100, I think you can buy a telescope that'll do a pretty nice job. Certainly do a nice job taking pictures of Saturn and Jupiter and the moon. The craters on the moon are beautiful. To take pictures of these nebulae is a little bit more of a challenge, because now we're talking taking long exposures, and that gets to be a little bit more of a challenge. But you can still do it, as I was saying earlier, with an inexpensive camera. I just used a telephoto lens I bought for $30. But you still need a nice mount, a mount that can accurately track for hours. And for that, you're talking at least a couple $100. And I haven't looked at the pricing for the lowest end of those things, but yeah, you need to have that.
Sure. Are there some things that you're looking forward to exploring with your gear in the coming weeks and months? I guess the summer is the most comfortable time to be out there, or spring or fall.
Yeah, the summer is the most comfortable. And I'm teaching a course for the freshmen at Princeton in the fall, which I taught before. By the way, this year it's online, so I'm not sure how that's going to work out. But it's about how to take astrophotographs and how to use those astrophotographs to understand how big our planet is, our solar system is, our galaxy is, the universe. And you can do these measurements just with a telescope on my driveway or on the student's driveway at their parents' house with relatively inexpensive equipment. And so I'm excited about that. That's only a little more than a month off before I get back to that, although I have no idea how that's going to work with the COVID thing. But the last 3 times I taught that class, it was really fun. And so I'm looking forward to it.
I guess that is more of a challenge, the online teaching.
Yeah.
It's there's so much learning takes place, I guess, face-to-face discussions, etc. You can do some of that online, but it's a little tougher.
Yeah, and these freshman seminars at Princeton have a maximum of 15 students. because they want the students to get to know the faculty. And it's been really fun the 3 times I've done it. Yeah, I actually got to know those 15 students. And the class wasn't like me lecturing, the class was us having a conversation. And I invited the students out to my house. They didn't all come at one night because that would be kind of a 15 people crowding around my one telescope might have been, but maybe 5 or 6 of them would come on a given night, and I'd show them how to use my telescope here at my house. But I'm not sure we're going to be able to do that this year. So we'll see how it goes.
Maybe if you don't mind, you can share with us some of those nebula or other photographs that you've taken. We see some behind you, I think.
Oh yeah, these are my 2 favorites. This one here is called the Dumbbell Nebula. I like to tell everybody it's named after me. And this is the Soap Bubble Nebula. They have more technical names. This is M27. I forget the technical name for this one. It's NGC something.
And what were you shooting just last night or this morning?
Shall I share a screen and show it?
Sure.
That's last night's picture.
Wow, what is that?
That's called the Ring Nebula. Because when it was first discovered, I don't know, 200 years ago, when telescopes were brand new things and there wasn't light pollution, the red outer part is actually the brightest part of this object, and so that was what it looked like, a ring. And so they called it the Ring Nebula. The star in the center, by the way, that's a dying star. That's what we're looking at. You see the dot in the center? That's actually a star, and it's old. And when a star gets old, it starts to expel its gas. And this is the same thing is going to happen to our sun, not next week, not next year, but I think about 5 billion years from now. But stars go through a life. Their lives last about 10 billion years, I think is something like the number. Might not have the number quite right. And of course it varies depending on the content and the size of each star. But our star will do this. This star was born earlier than ours, and so it's in its dying phase. And so it gives off its gas. And so the stuff we're seeing on the outer part is just hydrogen and oxygen, which are being emitted from the star in the center. And then the energy from the star in the center is just illuminating that gas. And so that's a nebula.
How long did it take you to capture this image that we're looking at?
Let's see, this was 20 minutes with my narrowband hydrogen filter, 20 minutes with my narrowband oxygen filter, and 8 minutes with a clear filter just to let all the light through.
And then you put it together with layers with software, or how do you put it together?
Yes, you put it together with a stacking software. I have some commercial software on my computer for stacking. Shall I exit full share screen, or should I keep sharing?
If there's another image or two you'd like to share, that's fine.
Oh, okay. I could share another image or two, I guess. Let's see. Would you like to see some of the other images? Like here's the famous Hubble. I mean, I took this image, but it's called the Pillars of Creation because the Hubble Space Telescope took a similar picture. The Hubble Space Telescope version is better than mine, but mine's not bad.
Not at all, and a lot less expensive than the
Exactly.
Hubble.
And
Wow.
it's really, literally, it's not that, I don't think I have a link to the Hubble picture here, do I? See, I've taken several pictures of it over the years.
Right.
I could just Google Pillars of Creation. Not Pillars of Eternity, Pillars of Creation. There's the Hubble picture of it.
Right.
There we go. So that's better. I'll admit it, that's better. But mine's not bad.
Yeah, but what you're able to do, and some of these anyway, you've taken right from home.
Every picture I've taken has been taken from home, except
Wow.
for the solar eclipse, where I took my small telescope to Oregon for the solar eclipse, which I can show you that too if you want, real quick.
Sure.
Let's see, we go to here, we go to here, we go to here, and we go to here. There's a sequence of pictures of the solar eclipse from 2 years ago.
Just beautiful.
Yeah.
Is that a flare?
That's the sun popping out.
Okay.
Oh,
I mean,
red,
on the right, I was,
the red thing was yeah, a flare. Yeah. In fact, if you scroll down, I have my a few favorite pictures. So there it is, right there. There it is closer. Oh, that's just a fake one. But yeah, that's it. Pretty cool, isn't it?
just amazing.
Yeah. So it's a lot of fun, I gotta tell you. So I got interested in it kind of randomly, but it's the joy of my life, besides my wife.
So Bob, looking at these images and what you do as often as you can getting out there, has it changed your thinking on what you're looking at and our place in this whole scheme of things, assuming there is a scheme of things?
One of the strongest feelings I had when I got started in all this 20 years ago, and I started well, first I started looking at a few of the bright galaxies that are out there. You know, nebulae are things within our Milky Way galaxy. There are other galaxies, which was discovered 100 years ago, that are not part of our Milky Way galaxy. And you're looking at this thing. It's a small thing, you know, but that's only small because it's so far away. It's a whole galaxy. It's as big as our entire galaxy. And there's that galaxy I'm looking at, either taking pictures or looking at, has billions of stars. And pretty much all the stars have planets. I'm looking here at 100 billion stars. I'm looking at 100 billion planets right now with my eye. I'm probably looking at an intelligent life somewhere there. It's just, I can't talk to them. They can't wave at me. Of course, I'm seeing this as it was like, you know, millions of years ago, because it takes light millions of years to travel from a galaxy here. So it's not like we can wave at each other in real time, but just looking at that and saying and thinking to myself, my God, there's probably intelligent life somewhere out there in that galaxy that I'm looking at right now. And because there's billions, as Carl Sagan said, there's billions and billions of stars and billions in our galaxy, and there's billions and billions of galaxies. I mean, the numbers are so amazing. This, of course, is a question that nobody knows for sure the answer to, but what's the odds that we're the only place with intelligent life? I think the odds that we're the only ones is, in my opinion, probably very close to zero, but I could be wrong. And so when I look out there and see things, just wow. And that really is exciting to me. And I think it's fun that NASA sends spacecraft to Mars looking for signs of life and stuff. We haven't found anything there, but that's just one planet out of billions and billions of possible ones. But the other ones are so far away, we can't go there.
Yet, anyway, right?
Yeah.
Hopefully we can believe that there's some science fiction movies and books that we love will maybe become reality.
Yeah. Yeah.
What's your sense? Do you think we'll be able to solve the problems needed to someday travel to these places that you're looking at?
I'm not optimistic that we'll solve those things in any relatively short future horizon. But in the distant future, I really have no idea. It is very difficult. By the way, people always wonder, well, if there's aliens out there, why haven't they come here? And of course, some people think they have, but my feeling is if they did come here, first of all, they wouldn't hide from us. They would say, hello, let us teach you more science because we're more advanced than you. I mean, when we came from Europe, the Homo sapiens, and came to North America and discovered species of animals that we'd never seen before, we didn't hide from them so that we could kill them and eat them. We, we were confident that we were okay. I don't think if aliens came to Earth, they would hide from us. They'd be
hopefully not eat us.
and they wouldn't eat us because their biology is completely different.
Right.
So unlike the Europeans who came to America, the animals were food, and so there was some benefit there in killing them, unfortunately. Aliens who came, if they came to Earth, there wouldn't be benefit in killing us, and they'd be a much more advanced species, and so they'd probably be a nicer species, I think. And maybe not nicer, but nice. And so I don't think we'd have to worry about them. So the question is, why hasn't that happened? And I think the obvious, to me, answer is because it's very far. It's not easy. Time travel is not, Captain Kirk may be able to do it, but I don't think it's going to be something people figure out how to do. And so that becomes a big question. Will we ever figure this? Will species that evolved on a different planet, hundreds or millions of light years away from here, take them, well, if they could do the time travel, or if they could go through a wormhole and come here, that's way, way more advanced science than we're even close to, if that's even possible. And so the question is, does that society last long enough? How many millions of years does it take to figure out the science of how to do these things? If at all, this is something we don't know. But the fact that they haven't come, I think, is an argument that it's not easy. It's not something we're going to figure out in 100 years. It's something, if Homo sapiens survive for 1 million years, maybe. But yeah, it's a challenge.
And is it okay if we steer people to your website to take a look at some of your images, Bob?
Yeah, absolutely. Yeah.
And it's vanderbei.princeton.edu/images, and it's spelled VANDERBEI. Again,
Wow.
vanderbei.princeton.edu/images.
Wow.
Bob Vanderbei, thank you so much for taking the time with us.
This was really fun. Thanks for inviting me. I enjoyed it.
And again, for the video version of this interview, check out the Techstination channel on YouTube. Now this. How many companies out there have continued to innovate when it comes to building a better radio? I'm Fred Fishkin, host of Techstination, and I'm here to tell you about the new CC Skywave SSB radio from the wonderful people at C. Crane. Bob and his crew really love radio, and it shows in this new compact model that is packed with features. Beyond great AM and FM reception and sound, you can tune into shortwave signals from around the world, listen to ham radio operators, aviation, and more. It's the radio you'll turn to every day, and in emergencies. It will run for nearly 3 days on just 2 AA batteries. Pair the sleep timer with the new Soft Speaker 3, and you've got the perfect radio for your nightstand. Of course, it can wake you up too. Click on C. Crane at Techstination.com and put in the code Techstination for a free flashlight with your order. They love radio, and you'll love C. Crane.